Um, I've tried to get paper source going, and I haven't succeeded yet. I found there's a I thought it was a GUI that I could use to see what's going on my server, but it's just an app that lets you run your shell inside this other app instead of going through the browser. So that turned out not to be of much value.
So you have your Paperspace set up, and so for your GUI, I guess you'd have to install a GUI environment, right? Like what is it called? XCFE?
Right. Yeah, I was trying to skip that step, but
okay.
Yeah. Well, I saw this thing on the PaperSource website, and it made it sound like it was a GUI, and I thought, hey, this is great. It's a custom-made GUI for that machine, but not the case.
No, okay. Yeah, I mean, let me know. I'm interested. I'm using it, but it's still, when I first got it, and for everyone else on this call, this is Paperspace, and we're just basically renting out a server in the cloud to do our work, because our machines locally aren't good enough. So when I first started, I really enjoyed it, and I was like, this is the future. I can use my iPad with my keyboard to do this. But the more I do it, the more frustrated I am about, like, sometimes there's lag, and I think I do prefer a local machine, and maybe I would outsource like testing. I don't know, but that's just my experience. I'm not as in love with it as I was last month.
And I've worked with a lot of cloud providers and spent a lot of time working with them, and that's pretty consistent with the experience I've had. So, I mean, if you get a big enough app where you can run in multi-tenancy, where you have multiple regions and multiple servers running underneath your app, so that you have on-the-fly failover and all that stuff, you can probably get the same level of performance. Otherwise, you're right. There's gaps when it goes down, or who knows what it's doing. Right, the network is glitching in and out,
And I did a quick Google maybe a few weeks ago, and it turns out Gazebo, at least most versions that we use, not Ignition, is not so much GPU as it is just clock speed. And I think the Paperspace servers aren't that, they're server grade machines, so they have multiple cores, but it's not so much a lot of speed per core. Al, I heard you were, oh, you're ready?
No, go ahead.
I was going to say, Al, I heard you're having trouble. Did you have any more insights? I didn't have access to your bag file, I found out today. If you're talking, Al, you might be on mute, but if not.
No, I was trying to find the mute button, sorry. Yeah, I noticed that I was looking at the Google Drive request. I thought I had put it in a place that was accessible, but obviously not. So I clicked on the approve button there. I mean, so I posted my error. I don't know if there's symptoms or problems or just annoying warnings that I don't know what to do with. But yeah, that's a little bit of progress in testing, but I'm still at a standstill.
So the handshake issue seems like it is a symptom. Based on my quick Googling, I know you did the same thing, but I'm not sure what it means yet.
And Matt posted a question or a comment about, if I haven't moved, and my GPS is constantly moving. I mean, even though it might just be a little bit, I'm constantly getting GPS signals, and it's constantly appearing that there is, let's just say an inch of movement. So I don't know in the bag file, Matt, what would I look for in the bag file to show that I'm getting a non data element?
Maybe in the heading topic.
Yeah, I can go back and look at that. So your theory is if the heading is ever non, something will break.
Well, yeah, there's a check for that at the top of that GPS ODOM, but there's not a check for it when it builds the transform.
Okay.
So to make that a little bit more robust, it needs one more check down there.
Yeah, I can go back and, I mean, my next step was going to be to add some info statements to GPS_ODOM just to see if I can see what could be triggering some of the issues, but I'm in debug mode, I guess, at the moment.
But isn't it nice to have a bag file that you can bring home and you don't have to debug it on the field?
Yes, I came tonight just so I could experience not getting yelled at by Vinny for not having a bag file.
That being said, that bag file I didn't look at the bag file, so.
Well, you didn't have read right, so there you go. But yes, it was able, being able to go back. I need to hone my bag file skills and play it with the clock, and then be able to look at the log files for the same clock period. So it was a little bit clunky to look at. I don't know if that's epoch time or what it is that the bag files are spitting out, and the timestamps that it gives you already. But anyway, I'm in debug mode is the bottom line, with a little bit of focus on GPS_ODOM to try to figure out why, what is apparently not working right. I don't know if anybody has got I posted another file. What is it? RQT graph. Is that the name of the, I guess it would be useful to have what it's supposed to look like so I could compare it to what mine looks like. So I'm not sure if anybody has what it's supposed to look like. Ross graph, yeah, that's the one I put out there. If I just share my screen, see if I can make this bigger. Whoa, that didn't work very well. Hold on, that's not working. Why isn't that working? Yeah, I'll keep putzing with that, see if I can get that to share. I'm on a Windows machine and I don't think if I can look at an SVG file very well.
Yeah, I don't know about you, but mine's like, I pulled it up and it's just very small.
I downloaded it, that seemed to help a little bit. So let me go back and share my screen. So this is in the same folder as the ROSBag file. And previously you guys were pointing at, so drive teleop is going into teleop command, going into command velox. Move base is going into there, going into command velocity, which gets into the low level controller. Again, if somebody has one of these that actually is, you know, the gold standard on how it's supposed to look, then it would be, I could compare that to what I'm getting to say, well, I wonder why I'm getting this instead of whatever the gold standard is.
I think the only other gold standard is the simulator, but as you know, that as it stands, there are some differences right now between the simulator and your system.
Yeah, and so again, this is the real world one too. So,
So I think we talked about this last time, but where's your move base flex command velocity going? Because ultimately we want that to go into the command velocity mux. And I
so
don't
there's,
think it's doing that. Yeah, it
there's
should be
move,
on the right of your mouse. And I think if you scroll up. Oh, I don't see it.
one more time, what am I looking for?
It'll be / move base flex / command _ velocity or vel.
I saw,
Yeah,
hold
so
on,
I
hold
know
on.
you have move base command velocity there, but
Can you do it? No, it's not going to let me do a find. I don't know is the answer to your question. I would,
Sure.
So move base flex / command velocity. That's what I'm looking for.
Correct.
And I'm saying this mostly for the recording so that I can look at it later. And we want it looking, we want it going into what?
That should be going into your mux, if it exists.
Yeah, so, I mean, there's the mux.
So there's, okay, so that command _ vel topic, what is the other, what's the other arrow leading to that? That's probably the origin of what
This
I'm
arrow
looking
coming
for.
up, is that the one you're
Correct.
looking for?
Yeah.
Get my mouse back off of that second screen. Yeah, it's
Goes
a
into
little
that
bit,
web.
yeah. Move
Scroll
base
down a bit.
flex.
Okay.
Yeah, if you're looking for it and it's not even on the page, that's probably a problem. And I have to be honest, I would have to go back and look at the timestamps to see when this was actually produced and whether those messages that were exposed in the ODOM, this could have been produced after those error messages, and that could have had an influence then on the output, right? So
Maybe, yeah. Okay.
but so that would be, I don't know, a symptom or a problem or both, that move base flex / command velocity is not appearing in your, you want to know what it's going in, what it's
Right,
going
because
into and out of.
I'm concerned that it might be bypassing your mux. That's all. It'll still work, but the mux function won't work at that point.
Yeah, it's not even,
Yeah,
not
that's
even
okay.
in the, it appears it's not even in the, it's not on the ball field. Yeah. No joy. Not to
Okay,
be, not to be
I'll try to
confused
look
with
at
the,
it. Go ahead.
I said I was going to make a pun joke about not to be confused with the joy node.
Yeah, I'll try to help out later this week.
Thank you. So Matt, you had said that you're able to run an autonomous mission. Do you have an RQT graph that you can share?
Mine's different than your robot. Mine's very similar to the simulator. So the simulator is sort of a good place to learn and then to share because we can all use that same setup. And if you understand how that simulator is put together, that will shed a lot of light on your own system.
Yeah, I'm confused then because I think I am using the simulator other than not running RViz. So what do you think I'm doing different than you?
Well, there's a number of things that are on your RQT graph. You've got move base and you've got move base flex. Those are two independent systems. Everything looks okay, but like Vinny pointed out, your move base flex is sending command velocity. And so you'll want to remap that to go to your command velocity mux.
And you don't have those things?
I'm not using move base flex yet. So those are just, but again, if your robot doesn't have odometry, generally what I do is I just, I kind of build in layers and I don't start any nodes that I don't need, especially when debugging, because that RQT graph can get very large. So you're not using move base flex yet. Move base flex needs odometry. And so if you're not able to supply it with odometry, it just doesn't matter. It doesn't work. It's not going to work. Like start there. So I would just comment out that because it doesn't matter. You need your joystick working and then you need odometry.
I think maybe it's just torturous curiosity. I'm not sure whether I'm in front of you or behind you. And if I'm behind you, it just seems like I should be following you. So when you say I'm using move base, the way you say it makes it sound like I'm doing something you're not. And I'm curious why I would be doing that because I don't want to do.
You're not even to that step yet. Like nothing works unless you have odometry. It's silly, but there's two things you absolutely have to have for your robot and nothing else matters at this point. Your robot has to be able to respond to command velocity. When you tell it to go 2 meters per second, it goes 2 meters per second. Tell it to turn left, it turns left, right, turns right.
Yeah, and with teleop, I can do that.
Okay. And then the second thing that you have to have is you have to know where your robot is. Nothing else matters. The planner doesn't work. Nothing works if you don't know where your robot is. Your robot needs to tell the software where it is. So like I don't worry about any of the other planning things or any of that other stuff until I get that locked down. Until I can point my robot east and my heading says that I'm east. I go in a circle, it goes in a circle. I go in a figure eight, everything looks good. I drive it 10 meters forward and it shows me, I drive it 10 meters forward in the real world. I look and I say, yes, everything is correct. And until that happens, the planner won't work, move base won't work, nothing will work.
Yeah.
That is an input. Your odometry is an input into MoveBase.
Yeah, I mean, I got on that sort of logic path thinking that yours is working, an RQT graph to compare to mine would be helpful. It doesn't sound like you're in that same ballpark, so I'll just keep trying to figure out how to get ODOM to work.
Absolutely. I wouldn't waste any more time doing anything else but odometry. Really understand what's going on. We're taking the lat and long from the GPS, and we're taking the heading from the GPS, and we're sticking those two things together. That's a very simplistic way, but maybe that's confusing. These problems also can be solved by buying different GPSs that output your position. Go to a dual GPS, and you won't have you don't have to worry about all these weird cases. It's, if you have one GPS, it's brittle. You need to move your robot forward. It needs 2 GPS points that are significantly different to get an accurate heading. For example, when I did testing, I needed to go above 0.4 meters per second before I got an accurate heading measurement. If you put on a dual GPS onto your robot, as soon as you come up, then it knows where you are. So you don't have to worry about, you know, checking your speed, making sure that you're heading, you're actually getting a real number. Like if your robot is stationary or if the points aren't far enough apart, it'll output NANs or just bogus data. So you'll need to do checks on all of those things. And another thing, like when you go into reverse, your GPS heading will be incorrect. And so what I do is I read the reverse switch on the lawn tractor, so I know that I'm going backwards, and then I reverse the sign. But again, just switching to a dual GPS will just alleviate all of that stuff. You don't have to do any of that.
So for you to run an autonomous mission, do you have a dual GPS?
No. No, but I have all of those checks. I check and see what is the state of the reverse switch. I check and check my speed. I know that I need to get my speed correct. So, but I've driven to get heading for a very long time, so it's not new to me. But a dual GPS, definitely, you don't have to worry about any of those things. Just turn it on, you know you're heading, you just go.
Yeah, I'll check my back file to see if heading ever shows up as a non.
So the only thing that you need is you need that heading message, and then you need that GPS point. And you're sticking those two things together. You can easily add complexity by checking other sensors and then adding Kalman filters and fusing different sensors. So, but the very basic is just take your lat long, take the heading from the GPS when you're moving forward, and then you're good to go.
Good deal.
Alan, how's your localization?
I don't know. I'm going to have a lot of questions I don't know answers to. Let me share my screen. All right. So this is, I put a video out last week, and I said it was VO, but it's not VO yet. This is the first step to getting VO up and running. This is just the camera added at this point. So using visual input for odometry or for localization. We're not using that yet. We're still working on getting that working. So
Sorry, what is VO?
visual, somebody's gonna have to help me with the exact. It's
Is it visual odometry?
Yeah, I don't know what the I stands for.
Okay.
But yeah, so it uses the camera. So it's a depth camera. This is the Intel RealSense D435 camera that we're simulating right here. And it's mounted in front on the rover. And you can see the field of view looks like this. And this would be the frame that we're seeing. And it's maybe not quite perfect because it looks like here it's a pretty narrow view in between these plants. But down here you can see the edge of the plants in RViz. So there's probably a little tweaking we've got to do to get that correct. But this is a point cloud that's being displayed here. And it's a color. So it has color in addition to depth. And so that's what you're seeing. Inside this frame is supposed to be the view that the camera would see. So, you know, a couple of weeks ago, we talked about the cost map, the local and the global cost map. And we weren't quite sure what was going on here at the time. So before I move the rover, before I give it a nav goal, you can see here, these are where the plants have been detected. These darker blue points are the points on the plant. So if we zoom in here, like this plant, it can't see this particular plant because it's hidden by the body. And the LiDAR is only set to go 180 degrees to the front in a half circle sweep. And there's LiDAR on front and back. So on the side, of course, it can't see that plant yet. So it doesn't know that there's a plant right here. And the LiDAR is off the ground. So you can see that it's not hitting at the base of the plant, it's hitting the leaves, you know, half a meter up off the ground, something like that. And so that's what you're seeing. These little blue dots here are basically each leaf showing up as little dots here. And then this square right here is the local map. And that will, as we start to drive, that will slide, that's a sliding square. It'll keep, this square will keep moving with the rover. The rover will stay right in the center of that spot. This is the RQT reconfigure tool. And one thing I changed from the other week, originally this was set to 12. And this is the range of the LiDAR. And I've shrunk it down quite a bit. I think it helps with the performance a little bit. But if I change that, for example, make it a little bit bigger, you can see that it sees plants further away. But if I put it back to 3, it just sees these plants up close. And so now, here's where I start to get into my questions. Before I move it even, like these plants out here, it seems to be building a cost map around that plant. And it's because for a while, I had this set to 12. So it could see these plants and started to build cost maps. And I think I'm saying that correctly. And one thing I'm confused about is whether that's on the local cost map or the global cost map. Because it seems like this is the local cost map right here inside of here. And then therefore this would be the global cost map. But I know in our discussion the other week, we talked about you would load a file into the program, a predefined map that would be your global cost map. And I'm not doing that in here. this is being built. So it appears almost like it's doing some kind of SLAM work while it's mapping this out at the same time it's localizing. So I don't know if what I'm saying there, that, yeah, go ahead, Vinny.
Do you, so I see you have a global cost map topic checked in your displays tab. Can you show us what happens when you, uncheck that?
Are you talking here?
Yeah. Okay. So it is populating your global cost map based on your point clouds.
Right.
But if you're not feeding in a map, like a dot, I think it's a dot YAML. If you're not feeding that in, I think you have some sort of empty map set up.
Right. Initially I do. So when this very first opens, there's nothing populated. These lighter blue teal colored dots on here don't exist. So I think it's pretty good. I think it's pretty good the way it's doing it because it's mapping, it's starting to map. And if I look into this a little bit further, I'm guessing that I could save this map and then in a future run, pull it back up. So it wouldn't have to relearn the environment every time. So I think that's one thing. The other thing, as it starts to drive, you'll notice that these plants, and I think a lot of this is going to be in the fine tuning. I'm not quite sure how much fine tuning to do in simulation versus trying to get it into the real world, but you'll notice that where it thinks these plants are, right now they're pretty clear that they're in these circles, and it's, there's some, what do we call that? If we go in here, right here, the inflation layer. I think if we increase this, yeah, then it starts to make a bigger, I'll call it a cushion, but you know what it means. It's basically inflating the obstacle to make it look bigger than it really is, just to make sure that you don't run into what you're supposed to be avoiding. So if I turn that back, so now as I start to drive it, these will start to, there's some kind of a disconnect in the readings that it's getting, because it'll think that the plants are moving when we know they're actually stationary. So I'd be curious what you guys think in terms of how to work around that, or what kind of questions to ask to fix that. So if I start to go ahead.
Yep. So if you don't have an accurate odometry for your robot, all of those things are kind of measured from where your robot is. And
is
so
odometry, by odometry, do you mean the wheel position measurements?
Where your base link is generally, what's the point of your odometry? And so, for example, if your base link is shifting, your estimate of your position is shifting, those plants will move because you know where your base link is, you know where your laser is, and it's just measuring the distance from that. And so if your base link is shifting, those things shift.
What would cause the base link to move?
Your odometry has a large covariance.
Can I change that?
Yeah, you can have perfect in simulation, perfect odometry.
Is that a setting that is configurable in here somehow?
I mean, I
So,
guess,
I mean, I guess what it should be doing, right, is it should, so as the wheels turn, it gets new odometry readings from the wheels, plus or minus any slippage, right?
It depends on how you're building your localization. Like, for example, AMCL uses your laser.
So to the extent that the laser is making good measurements, it should know where it's at, right?
Yeah, for example, if you put a wall on your blank map, put a wall so the laser has a solid surface to read from, like a box around your field.
Oh, yeah, let's do one of these guys.
You know, then it has a real solid surface to hit against instead of picking up those leaves. Look at that. Insert concrete wall. Bam.
Because I don't know how to rotate it.
In the gazebo builds window, kind of a little bit above where that concrete wall is, there's an arrow, there's an X, and then there's like a turning thing. So yeah, if it's the
Oh, there
one
we
that's
go.
highlighted, you can move that around with the left, right. Right now you have it on arrow, which is like select.
There we go. Let's just put it over there. So see, at one point it thought the barricade was right across here. So it started to add that to the cost map. But what's interesting is the cost map starts to disintegrate. So pretty soon that spot will be gone.
Yeah, there's a decay setting. And you can clear it if you want to.
So that's part of the recovery mode as well.
Yes. You'll get a twig in front of your laser and then it'll be an obstacle. It won't, and your robot won't move.
Anyway, I'm not seeing that in here, but I remember coming across it. So now you can see it's trying to plan around that obstacle that isn't actually there. So that's fun. And down here, one thing that was interesting, you can see the plants moving around in here. But I was able to, under the camera,
I think it's awesome that you're building all this in simulation first, Alan.
yeah,
It's cool.
it's pretty cool. There was somewhere in here, it's not changing right now, but the in the camera, under the camera, you can see the path. Yeah, actually, it's the green lines right here. You can actually see it on the same view, so you could you wanted to focus in on this view, you could see the path down in here. Well, I ordered the camera now, this 435, the D435 camera. So that should be coming hopefully sometime this week. And I don't know, I'm still working on this too. It bounces around a lot. It seems to have some kind of a glitch where it's jumping up and down. Sometimes just restarting yeah, it's doing that. The wheels appear to be jumping up and down, but sometimes just restarting that'll go away and it'll work better.
Is that an issue with your URDF, or is that an issue with your odometry? I guess the wheels are becoming separate from the rest of your model, right? So looks like it's an issue with your TF tree. Well, I don't know if your wheels are keeping track of their own TFs. Are they? Do you know?
Yeah, I think so. Right here. Yeah, I think they're all in there.
Yeah, that's interesting, but nothing's happening. Yeah.
I just paused it in Gazebo, which is pretty nice because then you can actually see what's going on over here. So there's, on the front side, there's, this is steering, front left steering, and then front left wheel. So the wheel is down here going this way, and then the steering is up here rotating this way. So I think now that thing has stopped bouncing around, it's a little easier to see. I think you're right, Matt. See how nice this object is positioned on the cost map versus the plants are much more dynamic. They're all over the place. And that's what you'd expect, right?
Yes. In the real world, are you going to use a laser for localization?
Well, as I understand it, I was going to use 3 or 4 pieces for localization. So I was going to use GPS, LiDAR, the camera, and the wheel positions.
Yeah.
And then that somehow gets all blended together and creates an opinion of the truth, I guess.
Yep. That's where that's where Vinny comes in. How do
I really know where I'm at when I've got every sensor is potentially off?
Kalman filters.
Yes.
I guess, do you guys know, is there an official Kalman filter package? When we tried to implement ours, we had to write our own, but I you know, being part of this group for this long has taught me that there probably is a ROS package out there and we didn't have to write our own stuff.
The one that you hear most about is robot localization. Have you used that one?
I haven't used it. I thought robot localization was like a stack, like nav stack, but is it not? Is it actually one package that I can, and that's a Kalman filter implementation?
Yeah. Yep.
Okay.
Exactly. So that's where you fuse all of those different sensors, and it takes in like IMU, different twist messages, different things, and then you can fuse them.
Do you also have to feed it? sorry to interrupt.
Mhm.
Do you also have to feed it a dynamic model, or is it unscented?
No, no, but there is another one from Lucas Robotics. I haven't used it yet. I don't really understand it, but it's called Fuse. And I think that one has a vehicle model where robot localization is just basically a common filter.
So there is this what you're looking for, the EKF localization YAML file?
Exactly. And that's where you put in
Oh,
all of
here's
your
another one.
sensors. Um,
So it looks like right now IMU is enabled in ODOM. That doesn't make sense, does it? Laser should be in here too, right?
what you could do is you could do like find what node is publishing your odometry message. Here's a tutorial that is pretty nice, talking about how robot localization works. But yes, Alan, exactly. Like you would get your AMCL would give you an estimate of position and an estimate of error, and then your wheel encoders, and then your, if you're doing visual odometry, all of those will output into this. Easier said than done. Tuning that can be it's an art. Localization is kind of it's a tough problem.
Well, and it definitely helps doing this because you can see what works and what doesn't.
Earth Rover has an open source localization package that they've been working on, but you need to buy the same sensors that they're using to make that work. So if you understand a little bit how that robot localization works, then you could use your own sensors or fuse new sensors that you want.
Did you have a link to that, Matt?
I'll show you here. There it is. And there was a tractor localization attempt out on the Ross Agriculture GitHub site. And that was using just a general GPS with IMU, but it was very difficult to use a low cost IMU. That the low cost IMU jumped around a ton, and when I was testing, I started to get really weird artifacts. Like right where I was testing was this like sub station with a bunch of electrical panels, And every time I drove by that thing, it would shift like 90 degrees, just like random. I don't know why, but so that's when I thought that the IMU, it was hard to trust that IMU. How would I know when it was giving accurate data? And I never figured out how to do that. And yeah, and then if you stop, then the IMU can drift also for some reason. It was tricky. I know some people can get them going, but I don't know about once you put them on a vehicle with the engine running and different metal things. They're pretty sensitive, and I never got it to work well.
So isn't I don't know if I'm going to say this exactly right, but wouldn't you generally want to, most of the time, trust that the GPS is giving you pretty good indications, as long as it seems that, I would think in the localization process, if it's moving steadily forward from one point to the next in a logical, somewhat straight pattern or a curve pattern or something, it's not all of a sudden 5 meters off to one side. I would think that then the GPS would filter through the Kalman filters and be a pretty strong signal. But then if the IMU said, hey, we're moving along pretty well here in a somewhat straight path, but then all of a sudden GPS jumps over 5 meters to the side, the IMU then would take over and say, okay, yeah, we didn't really move 5 meters because the IMU gave us nothing indicating that. Doesn't it take those types of things? And then if I add visual odometry to it as well, and the visual odometry is matching up with the IMU saying, hey, we're pretty much moving along as we planned, then I can wait for GPS to come back to be in line with everything, and then all three would be working together again. Does it work something like that?
Exactly. Yeah. With your
Okay.
estimate of position, it's called covariance, which is basically a square root of the error. And with a GPS, with RTK GPS today, it is very good signal, and it is very accurate. And you're right. Like when you get RTK fixed, your covariances are very small. I mean, there's very little deviation. And then if you were to pop out for some reason,
Like if I
you
drove
get
under a tree, for example.
exactly at that point. There's a status message on your GPS message letting you know that you are in float now, or
Right.
or yeah. So that's a very easy way to tell. So you can put in like a check for status check on the navsat message to see what status you're in. But your covariance will also start to get very large as soon as you drop into float, and if you go into whatever that other one is, GPS.
Right. And
But
then the Kalman filter will know that and just start to give less credit to the GPS signal.
exactly.
Okay.
Now that is a very simplified. That's how it works. But in the
Right.
real world,
Then
you're
just
going to
ask
be
Vinny.
popping all over. Yeah, that's when we asked Vinny, why are we jumping all over the place, man? It's the reason is one of the reasons is your GPS is giving you an XY position. Your visual odometry is giving you a relative position. GPS is giving you an absolute position. And so it can get a little tricky when you're moving in and out of fixed mode. Yeah, it's tricky.
Yeah, interesting. Yeah, I hadn't thought about the fixed mode versus float mode as being some kind of a signal that we could use. I mean, I've seen it, I know it's there, and I know what it means, but to use that as part of localization, that's really a good thought in terms of how much credibility do I give to the GPS readings in the localization.
Yeah, like you can do a real simple thing. Just pause. You know, like if you drop out a fix, then you pause or something until the system can recover. Obviously, adding more sensors adds more robustness. You know, you can go farther, and that's helpful.
So I shared my screen again. So would you put in the EKF YAML file, would you add something in here then? Is that where the, like your covariance table here, would you create something like this for whether it's in fixed mode or float mode?
No,
Or just,
one. Okay, so there's a couple of things that happen as you load your. Yeah, this will already be able to detect.
so it'll kind of automatically adjust for that. Okay,
Yeah,
okay.
there's. Yep. There are hops. The GPS hops, when you bounce in and bounce out, you'll come into a different position. But that's fine tuning. And if you're in open field, it's really nice. The GPSs are really nice.
All right, well, cool, good stuff.
Anything else for tonight's meeting? All right.
Everybody went quiet.
Yep. So, time to go. Good seeing you. Good luck on localization. Vinny, don't work too hard. Get some playtime in, but don't get sick down there in Florida.
Oh yeah, it's miserable down here.
So, all right. Hope you guys
Cool,
have a
well,
great week.
thanks for your input, guys. Appreciate it.
Good night,
Yeah.
guys.